Find the domain of the function. So finding the domain, in fact, is the same idea. We are looking for the x-axis. So let's look at the example. Find the domain of the function defined by the equation of y equal 1 over x squared minus 5x minus 6. So this is a rational function. So finding the domain of the rational function, as long as we can make sure the denominator you will not get a 0, then that will be okay. So we finding the factor form of the denominator. So we will have x here. The product of two numbers you can get a 6 will be 1 by 6 or 2 by 3. 1 by 6 or 2 by 3. Since the middle term is a -5, I will pick this pair. So I put a 1 here, put a 6 here. The middle term is -5, that means the larger number goes with a negative sign and the small number has a positive sign. So once I have the factor form ready, if I draw the number line, x plus 1 equals 0, that means x equals -1, right? X minus 6 equals 0, that means x equals 6. So I have the 6 here, and then I have the -1 here. Okay, so that means as long as I can pick whatever number I want, as long as I don't see these two numbers occur in my number line, then the whole function will continue forever. So we have to skip these 2 points. So if I use a notation to represent the interval, we will have 3 intervals to represent this equation. So we have the -infinity here. This is a positive infinity. So the first interval will be -infinity, comma, -1, union, -1, comma, 6, union, and then 6 to the forever. So that will be the domain of this function. Evaluate the function. So the function notation is y equal f of x. So it could be y equal x plus 1. It could be y equal x squared. It could be y equal cubic root of the x minus 1. So they are all the function notation. If I can tell the x, substitute x into it, you will solve for y. So let's take the example. This question has the function is this 3 term. Now they want to know when g at that point at the x equal -3, what will be the y value? So keep in mind, when your input is the numerical, your output must be a numerical as well. So we substitute a -3 into here. So it turns out it has this 20. So this will be the output when x equals -3. G of k, that means the input changed to the k. So I just simply to write down the g of k is equal 3k squared plus k minus 4. So your input is k, your output must has a k. Your input is a -3, your output is 20. Now the input has -t power 3. So same way, I just write down the g of -t power 3. And now we will have 3 multiply -t power 3 to the square plus -t power 3 and then minus 4. So here we clean up we will get 3 multiply. Now this one is the same idea. You have negative t power 3 multiplied with another negative t power 3. So negative sign multiply it into the positive. And the t, you will have power 6 minus t power 3 minus 4. So this will be the solution of g of negative t to the power 3. Now, when you have the g of k plus 1, the independent variable change to the k plus 1. So we just simply to rewrite the function into 3, multiply k plus 1 square plus k plus 1, then minus 4. Now we need to extend this part. So we'll have 3 times k plus 1 multiplied with k plus 1 plus k plus 1 minus 4. So distribute these two, we will get a k squared plus k, you have plus 2k, and plus 1 plus k minus 3. So you have 3k squared plus 6k plus 3 plus k minus 3. So it turns out you have 3k squared plus 7k and negative 3 is 0. So when your input has k plus 1, the output is 3k squared plus 7k.